Good morning, Tahmina Khan is here in TKMaths is Fun. In today's video, we will see a question from M1, which is part of the syllabus of A Level Mathematics, and it will help you to revise the concept of energy equation, constant acceleration, resolving of the forces. So I have picked up two questions. I'm going to make two videos. This is number one. So let's start. In this question, you can see the situation that the particle is on the flat surface and on the ramp, right? So I have highlighted all the important point. Theta is not given to you here, rather it is given to you in the question. Sin theta is 3 upon 5. And particle of masses are given to you. A has mass 0.3 kg and B has mass 1.5 kg. Initially they are at rest and the system is released from rest. It is written here, right? And string is taut means there is no slacking in the string. So it is very tight. Okay, so now what is given here, you have to find the, in part 1, acceleration of particle A and the tension in the string. And let's start with part 1. And in part 1, the surface is smooth. Situation is same, but in part B, the surface is rough. And then we have to find the acceleration of particle A and the value. So let's do part 1 first. So here I have written down the information from the question, and I would recommend that when you read questions, because they look very lengthy, you can see it's better when you are reading, start writing down the important points separately so that you don't have to read again and again to get the situation. Now what I have done here, if you see, it was given to you that sin theta is 3 upon 5. You can also find angle from here and then you can use it accordingly, but it is not exactly, right? Because it will be decimal and you will round off. So that's why I would recommend that using this concept, I'm sure you know it, by drawing the triangle, you can easily find out cos theta because we will need this in the question. So first part of the question is find the acceleration and the tension in the string. So let's start. So you have to resolve the forces on the diagram to give a better picture to yourself. Some people do it mentally very quickly right then and there. But at times there are questions in which you have to show all these resolving forces. So it's better you do it. So if you look at particle A, because the surface was smooth, so the backward force, which is a frictional force, at this point is 0. Tension I have written is same because they are passing over a smooth pulley here. So that's why tension at this point near A and near B will be same. Masses are given to you 0.3 kg. To change it into force, we multiply by 10. This is the standard we use in maths, otherwise it is 9.8. Okay. So similarly, I'm resolving at B. The force is parallel and perpendicular to the plane. So this pink one is given to you here as a weight which is acting vertically downward. So when I resolved it, here perpendicular to the plane and then parallel to the plane, right? So definitely this angle is theta. So this side will be 15 cos theta. Now 15 is what? Is the force of this string. The mass was 1.5. Now once you have completed this diagram, now let's start. The target was to find the acceleration and the tension in the string. So I am making here two equations. There are three ways to solve it. I am solving one way first. So when system is released from rest, particle slides down, applying Newton's second law of motion at A at B. So I have shown you here, just a minute, here Newton's second law of motion. And for particle A, if you see here, the forward force is T and mass is 0.3. So I have written here this equation, T is equals to 0.3A. Similarly for particle B, forward force is this 15 sine theta, which is here, right? This is forward force going downward, and the backward force is the tension in the string. So resultant force will be 15 sine theta minus T is equals to 1.5A. Now you have two equations, you solve them simultaneously. I have done it here for you, and you can get the value of A and T here. Now once you have the value of A and T, part 1 is solved. Now let's come to part 2. In part 2, the question was asking for finding the acceleration of particle A and the value of coefficient of friction. Now what is given to you? Block is on rough surface now. So the coefficient of friction, let me change the color so when I write you can see where I'm writing. The coefficient of, first line, the coefficient of friction between A and the block. So you have to find here now coefficient of friction on this surface which is rough. That's why now I have written here mu r, because now when this particle will move, it will release from rest, there will be a force acting backward which is called mu r, maximum friction, right? And similarly it is saying A does not reach B, P. So when it is moving, we are talking about 3 seconds in the question, second line you can see here, that in the first 3 seconds the particle A will not be able to reach P here. It will not, right? It will be somewhere in between. Okay, so what we will do now, first of all we will find out the new acceleration now, right? We cannot use this acceleration because this was the case when the surface was smooth. So we will find out the new acceleration. And what is given to you? That in 3 seconds the speed of the particle is 5 meters per second. So this is given to you. So V is given, U is 0 because it was at rest, time is 3 seconds, acceleration I can find out using the constant acceleration formula. Okay, so I found it 5/3 or 1.67. I would recommend to use the fractional form to substitute in the exact form to get the answer. You can use this also, but it's better to be more precise. Now, when particle is moving on the rough surface, of course when it will start moving, it will experience the maximum friction which is mu r, right? So now we will apply Newton's second law of motion, and what we are trying to find out now? Coefficient of friction, mu. Acceleration we have found. So now what I'm doing here, if you see in this part 1, this is Newton's second law of motion. I'm applying it on part A and at B separately. That's why I've drawn the line. So now this is your resultant force, right? Particle A, if you see here, this one. So it is T minus mu r is equals to ma. And this is what I have done here. You can see here. F is equals to ma, T minus mu r is equals to 0.3 over 5/3. This is my equation number 1. Now I have to make equation 2 at B. Now if you see B, same thing, this is your forward force and this is your backward force. So I will do 15 sine theta minus mu r. Okay, so now this is my second equation. You can see here 15 sine theta minus T minus mu r. Now why did I write minus T also? Because here it is not only tension, but it is also coefficient of friction also acting on it, because surface is rough now. It was given to us in the question. So now my resultant force will be 15 sine theta minus T minus mu r is equals to 1.5 times this. Now you have equation 2, this one, and you have equation 1. Now you have to solve it simultaneously. I have done nothing else. So when I solve it simultaneously, I expect that basic substitution in algebra you understand. When I substitute it, I got mu 0.4 and tension 1.79. Since I avoid working in fraction and I recommend the same for others, so from this equation, I have made equation 1, I have made T a subject here. And this value of T I have plugged in the second equation in this place. You can see here. And then it is a simple equation. I have solved it to get mu and then substituted this coefficient of friction back here to get T. Now the question is solved here. What else I have done here? At times question will say solve it by energy equation, right? And one more thing very important, which is also conceptual, rather than dividing it into two parts, like I have done here, Newton's law is applying at A and at B and then solve simultaneously. You can consider the whole system as it is, which I have shown here. So this whole working can be reduced a lot. What I have done here, see here in this equation. In this diagram, if you see, your forward force is this, okay? T here and here are opposite to each other. So their effects will cancel out. So if I take this as a forward force, then backward force is what? Mu r at B and mu r at A. So I will do forward force, which is due to weight, minus both the mu r, which is the maximum friction at A and at B. This is what I have written here. Friction at A and friction at B. I hope you understand how I'm making the resultant force here. Is equals to ma. Now in case of ma, definitely I will use the mass of both the particles A and B. Okay. So now after this, I am simply substituting values here. We have already calculated frictional A, which is resultant force. You can see here resultant force in red, in green I have mentioned here, right? So these values I am plugging in here. And I got the mu here. So within 4 lines I have found the value of mu, right? Because question was asking only in this part, mu and, coefficient of friction and acceleration, which you have found earlier. Now, sometimes you will see the question will bound you and it will say solve it by energy equation. Then what you have done here, you cannot do it. You have to solve through energy equation. Now, what is that? Let's see here. The diagram is here again for you, right? Energy equation is what? When the system start moving from the initial to the final stage, you have to find out the initial mechanical energy. In mechanical energy in your syllabus, we include kinetic energy and potential energy. So initial mechanical energy is equals to final mechanical energy. This is about energy equation, because energy cannot be created or destroyed, the concept. So it can change the form. What I have written here, because in this case, kinetic energy initially and kinetic energy finally are not equals to each other, there is some work done on the way. And what was that? Work done against friction. So from the initial kinetic energy, some of the energy is transferred here, and then I will reach to the final kinetic and potential energy. So this is a basic energy equation. Now I will start substituting values in it. Okay. See here. So kinetic energy and potential energy I have written here for particle AB and potential energy AB, right? So I am talking about this part first. What is the kinetic and potential energy here and here? Because it is a horizontal surface, right? So potential energy initially and finally will remain same, because when particle will move from here to here, there will be no change in the height. When there is no change in the height, I'm considering it as 0. Okay, whatever reference we are talking about, but they are same, so it will be 0. We are not considering it. Now, work done against friction, and that I will take as minus. You know why? Because it is against friction. Okay, and what is work done? It is force into distance. See here, force into distance. And what is the force here? Frictional force, which is mu r. So this is done. Substitution I will show you later. And here I have written the formula for you. Half mv square plus mgh, both for particle A and B. Similarly here, right? So now initially particle A and B are at rest. So that's why velocity will be 0 and answer will be 0. Similarly, for particle A, initially it will be 0. And if you see here, finally also it will be 0, right? Now what happened? If I look at particle B now, okay, now focus on particle B initially and then finally. For particle B I am talking about here, right? A mein to there will be no change. Now look at this diagram. Let me tell you which one I'm talking about. This one. Focus on this diagram here. Okay. Now if you see here, this is the position of B when it was on the ramp. Let me show you where it was. Here. Okay, I have drawn this part of the diagram separately for you to explain that particle is going from here to here. So what is the change in height? So this is what I'm trying to explain to you here. Now, the particle is here. The distance it will cover, we will find out. I have written here the value which I have already found. but right now it is unknown. So we will find this out. Okay, and let me call it d right now. Okay, and this is the height which is changing in what? In potential energy. Ground I'm considering as a reference, so height here is considered 0, and this height is what? It will be, if you see here, with respect to this theta, it is sine theta is equals to opposite over d. If I write here h over d, because I will find the value of d, that's why I have written here 7.5. So I got my height as d sine theta, right? So I will write the value of d. So remember this concept first of all. Okay, now I will show you how I have found the value of d. Let me erase all this. Okay, so now if you look at this diagram equation again, I know height, which I will find out. This is your mass and gravity, which is 10. So you know this value also. Mu r you will find out. Distance we have just found here, 7.5 here. How did I find out? I will show you here. So this is the energy in which I'm going to substitute the values. Okay. So now look at it, how I will calculate the distance, because the time was given to you 3 seconds. So you are writing the constant acceleration formula, which is s is equals to ut plus half at square. Okay. And you found the distance 7.5. This is how I am substituting it in this place. Now see here, the substitution is happening here. I have shown you here, how did I find force into distance? Because force into distance is because of both the frictional force. So it is mu r because of A and because of B. I think this part is clear because we have already found the values of mu r. Now, after the substitution of all the values, because now we have everything, I got the mu 0.5. So I hope it is clear. Here I am just writing masses. And why did I write 0 here? Because this is the last stage of particle B reaching the ground. So please ask question if you have any clarification required.